Okay. How do you just got done with number 12?
Kind of.
Well, really, or no?
That seems like an issue though. The negative one. Where do you absolute value?
Okay. If you were to integrate this, then do you get something like x plus c, I guess?
I know what you're saying.
X plus c equals natural log of the absolute value of y, yes? If you use the initial condition of 2, -1, that implies that 2 plus c equals natural log of the absolute value of -1. So c is -2, yes?
Wait, wouldn't it be?
Mhm. Okay. So x minus 2 equals natural log of the absolute value of y. If we exponentiate, e to the x minus 2 equals the absolute value of y. The absolute value does not go away as much as you might want it to. When you dump absolute value, generally speaking, you say if the absolute value is removed, we must consider it could have been positive or negative to begin with. So when I dump that, y is positive or negative e to the x minus 2. And I choose based on the initial condition. Well, the only way I'm going to get a -1 is if y is defined as the negative branch of the function, yeah? So based on 2, -1, that implies that y must be negative e to the x minus 2. We? Okay. That's your
Confused them. Why would you? So I wrote it as x equals natural log of y plus c.
That's fine.
But then when I plug in 2, -1, then your c ends up being positive. So yeah.
That's true, but when you then, so if you had that, x equals natural log of y plus 2, when you solve for y, which you must do,
You end up solving.
it'll be minus 2 in a minute. So okay, let's go to your lesson. I believe this is the last derivative technique chapter, or part of the chapter. After this, you have complete derivative technique. That's until you get to top 3. All right. So, before I get to the calculus of inverses, let's review the pre-calculus of inverses. If I gave you this table of x and f, complete the table of x and inverse f. All right, and so would you agree the big idea of inverse is the old switchy switch? Yes? No switcheroo. So the tables should be reversed. Check. Let's go to analytical. If I was to prove two functions are inverses, then they should undo each other. If I take a number, add 2, subtract 2, that undoes each other, you're right back to what I added to begin with. Remember, I put it to begin. Inverses should undo each other's effects, and you're right back to whatever you put in with to begin with. What is the inverse of x plus 2? I will. Could you be tempted to call this y? Do you like y's or do you use function? Okay, well, stop that. Okay?
Why did you ask us?
Because I wanted to see if you're wrong, and it turns out you are. Okay? Here's my problem. There's the original function, right? Here's the new function. That's the inverse. Is there any notation to indicate those are two totally different things, and now I'm dealing with the inverse? Or do those y's look exactly alike? Exactly alike. And so that's the liability of x, y notation. There's no differentiation between those. But if you call f this, and you switch, the minute you switch in function notation, you have a way to say, now I have the inverse. This is the inverse. That's why I prefer function notation, and that's why you should prefer function notation. It allows you to differentiate between the original and the inverse. Okay? Now, if you want to show their inverses, then f of f inverse would be, I put f inverse into f, and I get x minus 2 plus 2, which is
X.
x. And if I put f into f inverse, then boom, that would be more like x plus 2, x or minus 2, which is x. From that, we could conclude that f inverse of x minus 2, or equals x minus 2, is indeed the inverse. Not everything has an inverse, by the way. We'll talk more about that later. But that's good for now. All right, you with me so far? Cool. Would you find the inverse implicitly and explicitly of that function? Go. Box both answers, please. Howdy.
What is
So,
the difference between
is this y inverse or 1 over y?
Yeah, that's what I was thinking. Like, also, I thought about this could be.
Oh, okay. So just solve it.
Yeah, if you, this most definitely needs inverse. If I want to talk reciprocal on function notation, you would absolutely.
What's up?
You just feel like, why?
The way they do things just makes so many questions.
I hear you.
I just feel like things don't get these things.
I hear you. Take it up with Cauchy. He was the great janitor of the calculus. Okay, so would you agree that x equals 2e f inverse plus 3 is my first answer?
I would agree with that statement.
I don't think that, I guess I shouldn't say a hard no, but I've never seen that applied to anything but hard. So you could say that E is like arc y. I've never done it. Arc
That's
y.
not terrible. Yes, who would say arc y? That's so funny. Arc x.
Okay, do you agree that that is f inverse?
Do you have to put absolute values around that?
You do not.
Clearly, yeah.
That is an integration idea. Please don't get in the habit of saying anytime I stop an natural log function, it's absolute value. That's only on the integration. Okay.
Thank you.
All right, are we good? All right, here we go. Would you please show me the graphical relationship between that cube and its inverse? I'll let you do the inverse dotted, please.
Oh, we grab it.
Here's the symmetry in a function and its inverse.
About the origin.
It's about the line y equals,
Or y equals x.
it's about the line y equals x. Okay? And that actually makes a whole ton of sense because what do you do when you find an inverse? You take x and y and you switch it. And if I switch x and y, isn't that going to reflect right across the front? Yeah? Okay. Now, let's talk calculus here. Here we go. If you were to take, these are lines at these points, go away. Okay. Would you write the square root function accurately, please?
I could do that.
At all integer values or integer y values? Dang it. And then what does it say to do? Sketch the tangent at x equals 9, please. Darn it. Having a rough time. Still in there. Aha. Okay. Yeah. All right. Are you with me? Now the idea is, okay, that's the slope of the original. What if we were talking inverse? So now what I'd like you to do is graph the inverse of f. All right. Now this has a mistake in it. Sorry. I said graph the inverse of the function and the tangent to the point corresponding to x equals 4. That's done. To this point x equals 9. What point would correspond to x equal 9 on the original? Yeah, x equal 3 on the inverse. Do you agree? An x of 9 on the original would go with a y of 9 on the inverse. And so instead of focusing on the point 9, 3, let's look at the slope at what's going on at the mirror image 3, 9. And if I look at the slope at 3, 9, okay. The idea is we take a look at what happens when you take the derivative of an inverse. Now this slope was flat and positive. This slope is still positive but steep. So does it feel like negative reciprocal? No, because it's obviously still positive. But it is definitely reciprocal. The only gotcha, though, is it's not at the same point. The derivative of the inverse is the reciprocal of the derivative at the inverse point, or at the y of the original, at the inverse point. And so the derivative at the inverse point of 3 would correspond to the derivative of the original. We went over the derivative of the original at 9. Let's go here and prove it, or talk about showing it. We just talked about how the main relationship of a function and its inverse is that they undo each other. If you put an inverse into the function, they should undo each other's effects, so you're right back to the x where you started, yeah? This is the best place to develop a rule for the derivative. If I want to rule for the derivative of the inverse, now if you didn't like the notation on the previous page, you definitely won't like this. This is the notation for the derivative of an inverse, f inverse prime. It's ugly, but it is what it is. Would you try and find for me a rule for f inverse prime? Go.
Okay, so
the inverse of f. That's fine. We can say the inverse of f.
No, that's ridiculous. I just said.
So you're getting something like that. Going over the normal derivative. This is the hard part for students. It's the normal derivative at the inverse of the point they asked about. Now that part is the part that we'll have to practice. The derivative idea is not hard. It's the inverse part that's confusing, all right? So that is the rule. 1 over the normal derivative at the inverse point or at the y of the x they asked about. So if they want, I don't confuse you. Here we go. So this is common book kind of problem. I gave you a couple book type, and then we'll talk AP type. So if I asked what's the inverse derivative at 2, and I would say the inverse derivative at 2 is the same as 1 over the derivative of the normal function at g inverse of 2. In other words, I start by just basically putting down the derivative rule itself. Now I go to details. Now I usually, and I recommend you do the same, work inside out. I can't find the derivative at anything until I know what I'm going to put into the derivative. So g inverse at 2. Now we're going to find that. Find g inverse at 2. If I say g inverse at 2, then in the original problem, where do I put 2? In for g or in for x?
In for X.
Wouldn't that just be g at 2?
You put G at 2. Yeah, I knew that.
Okay.
That's what I was.
So remember, on the inverse, that's actually the
Answer.
answer. So that should go there. Now, the good news, you might think, oh, so am I going to have to do all that cube solving answers? No. Almost all of these will be guess and check. You can just see that x is 4. Okay. So if I guess and check, x is 1. Now that said then, the inverse at 2 is 1. Now I put that into the derivative, and that's my slope, the reciprocal or flatter slope. 1 over 3 times 1 squared plus 1 or 1. 2. My slope. Are you with me? Okay. Try the other one. So maybe, yeah, it's still pretty guess and checky, isn't it? So I think the answer? One third? Okay.
Wait, what?
Did I make
Where'd
this
you get
one?
for your
I
X?
got 1 half.
Oh, okay, 1/2. I got 0 from saying the inverse at 2.
I understand.
Okay, we're good? Okay, are we good with 1/2? Any
Not yet.
questions? Okay,
Oh, because you can't.
let's try gradually a little more complex, or not too hard, don't worry about it, but how about this guy? If try this one on your own. I don't think you need me to hold your hand. Now this one, obviously, you have many answers to sine equals root 2 over 2. Take the domain to find one, the range to find one of arc sine. Should be between negative pi over 2 and pi over 2. So pi over 3, yes? So did you get something like 2? Yes?
Hey.
Okay. Try the last one, then we'll go to more AP stuff.
Oh. like this whole thing.
Yeah, it makes me feel pretty good.
It's like I got 12 yesterday.
Yeah.
That deserves a couple. Fantastic for everyone getting ready. I know.
You get a 1. Okay. Is this going okay? No? Okay. Try the, instead of analytically, graphically, numerically, so that we will be good to go.
Why not? Does it literally say?
So that's the Y.
That's G prime. That's my first. That makes sense. So it's just
Did you get 1 half?
no.
Oh, did I make a mistake?
Possibly 1/7.
Yeah, I think it's
1 7?
Oh, no.
Because G prime of 1 is 7.
Oh, yeah, I got 1/7.
G prime at 1.
Well, they gave us the graph. Oh, we did the table. Maybe that might be why.
Oh, these are different. Those are 2 different properties.
nice.
Okay.
So then as
Oh
it
wait,
goes out,
are you
I probably
So they both end up having 1 over G prime of 1. That's the mission. That's weird. So.
determine
Well,
this
you
one.
think apparently you're right.
Inverse at 2.
Okay,
So then, Mr. Rickman, wouldn't it be G prime of 4?
There what?
1 over G prime of 4 for the first one. If you're gonna do the
G-
inverse at 2 is
So
4.
G prime at 2, does that mean I go
Oh,
to the
no, just
original, look
kidding.
at an X of 2
No,
or
I
Y?
did that wrong. You're right.
So this means Y equals 2 on the original. So what does X equal? That's 1. Okay, so I got 1 half for the graph problem. Do you agree?
Yes.
Okay? And I haven't finished this one, but does somebody want to throw out their answer? 1/7. Do you all agree?
Actually, good idea.
All right, that's it. It's pretty straightforward. It's a small idea. I mean, it's important, but not huge. There's always a multiple choice on it. And once every 3 or 4 years, it's good. Okay? So, questions on set 91? Well, we're caught up, baby, and we're staying there.
Yeah.
Huh.
Well, we don't have a 7th.
Everyone?
We don't have a 7th hour today.
Did we finish the video? Oh, it's all on. I was actually absent.
Except for the one.
Do you want to know the Wi-Fi?
Stanford.
Not for Stanford.
Oh, and 20.
My uncle's apartment in California.
Absolutely. Yeah, 20 is a good one.
16.
I can do 17.
That's a one. What class is that?
I don't have them. Got the actual paper, but yeah, it's not. One side.
I mean, it makes sense because he's just arbitrary.
Okay, so So obviously there are many cylinders you can place inside the cone. The question is what's the one with maximum volume? So let me catch up to you to get to B. We know that the cylinder volume is pi r squared h. And gosh, you would like to get that down to two variables first. If you use the similar triangle idea, then within the cone, or the half cone really I'm going to look at, within the cone there is a half cylinder. This is the height of the cylinder, which makes, and if this is 6, this is 6 minus h, they give you, this is the radius of the cone, and this is the radius of the, oh, sorry, that's the radius of the cylinder, that's the radius of the cone, 4. Okay, so by similar triangles, 6 minus h is to r as 6 is to 4, yes? So what do we want to solve for? 6 minus h equals 3 halves r. That's about the same either way. Would you agree that r is 2/3 6 minus h? Is that how you, did you solve for r or solve for h? I don't think that is. Is yours r, you know. Do you mind if I do that? Yeah. Are you good with up to that point? Yeah. Okay, now the reason you wanted to do all that is to get your calculus down to 2. That's just a fundamental truth of calc, especially important in multivariate. If you can get it to 2, get it to 2. And you can't always, but in this case you can. So 2/3 6 minus h, 6 minus h, what the heck is going on? I'm plugging in for r, I apologize. So in place of r goes 4/9 6 minus h quantity squared h. Then decide, do you want to use the product rule or you want to distribute it out? I'm feeling distribute it out. So this would be 36h minus 12h squared plus h cubed. That's, now that was a lot of work up front, but now the calculus will go smooth. dv dt, no, sorry, it's not changing with time. Different volumes with different heights, so dv dh, 4 pi over 9. 36 minus 24h plus 3h squared. If I pull out a 3, I have 4 pi over 3. 12 minus 8h plus h squared. That is factorable, -6 and -2, or 6 and 2. So if I go 6 minus h, 2 minus h, I believe that factors. And so my critical numbers are h equals 6 and h equals 2. Are you with me? Okay, now, one of those is a max, one of those is a min. Use your common sense here. The height of the cone itself is 6. If you make the cylinder height 6, then that is not a maximum volume, that's a minimum. There's no volume. Okay? And so this is a min. The greatest possible case would be when height is 2. I could side test and show it's a max. I take my word for it, height is 2. If height is 2, the radius is 2/3 of 6 minus 2, or 8/3. The volume of the maximal cone is pi r squared h, or pi 8/3 squared times 2, or 128 pi over. Okay. Units cubed. Okay, cool. 20, question on 20. Is 20 still a question? Okay. Okay, so this is meant to be an application and an evaluator, yeah? Okay, so this joker, probably a teenager, he passes the policeman at 6 o'clock and he's going 65 miles per hour. Yeah?
PDI.
Probably because he's, speed limit's 70, so he probably,
Is it reasonable?
The speed limit is 60, so it's going 60, and it's a.
oh, he's going 60.
It's not a teen.
Okay. He's a teenage trucker.
That is not a thing.
It is, it's not a thing? There's no such thing as teenage trucker? You're right, they would never trust a teen trucker. Okay, so, 1 hour later, this is actually how they used to do speed traps. 1 hour later, trying to go for 3 dimensions, but it's not working out. At 1 hour, he slams on the brakes again as he sees the policeman, and he's going 60 miles per hour. Okay,
70 miles apart.
but they're 70 miles apart.
He's going at least an average of 70 miles per hour.
Yeah, now his argument is, wait a second, I never broke the law. When you saw me, I was going 60. And the judge says, hold on. By the mean value theorem, there must have been an instant where you are going 70 miles per hour. Done. Proved. You would say, do you say the position is continuous and differentiable, or the velocity is continuous and differentiable? Position is continuous and differentiable. We want to make a conclusion about the instantaneous change in position. So x, or position, is continuous and differentiable. And differentiable. So by the mean value theorem, there is a time in the instant, in 0 to 1, when the velocity or the derivative of position at that time is equal to the average rate of change, which is change in position over the time interval 1 hour. That is 70 miles per hour. He must have been going 70 miles per hour at least once, and in fact, he must have been going over 70 miles per hour if his average rate of change is 70 and he's going 60. He must have exceeded that. All right. Yeah, you're welcome. Okay. 16, question on 16.
Most likely.
16, yes?
Despite saying
Is there a place?
16. No, it's not.
Oh, don't you have the answers?
Yeah, but I you will.
Oh. I have a paper copy. I have a paper copy. Oh. Oh, yeah. I have paper. I should have. Shell method around the x-axis.
I drew it like multiple ways and then crossed off.
Oh. You don't have an eraser?
Well,
I hate it. Erasers are the worst.
Really?
Oh, I like zero to three.
Like even if I'm using a pencil and I get something wrong, sometimes it just scratched out.
That's what this is.
Oh. Doesn't that make it look ugly?
It does,
Yeah,
but like,
it
I don't
looks
like
pretty great.
Do you care about the look of the product?
if it's in like if it's on like a test or something, I'll
I got it right. Don't worry about it.
even if it's like scratch work, I'm just like
Hey, if I'm going to use a shell, does that imply I have to use Y or X? Y. If they determine, I could use this if they didn't show me, if they didn't say, and this could be X. But they said use shell. The only way I'm going to get a shell out of this around the x-axis is if I use Y. So, this is something like volume is 2 pi, the radius is x or y. Y, and the height of the shell is the curve to the axis, and so that's 9 minus y squared. From 0 to 9 or 0 to 3? 0 to 3. And does it say set up or fun? Fun. Okay. So the antiderivative of 9y is 9y squared over 2, and it's y to the 4th over 3. I was kind of distributing and
yeah,
anything
it's like
different. 9y, derivative of y is y squared over 3. I was distributing.
No, for the Y over 3.
So over 4.
I don't know.
All right, my bad, I don't know what I said.
That's fine.
Yep.
Okay, so 81 over 2 minus 81 over 4.
I stashed in Haller too. Haller's funny.
So I'm feeling like 81 pi over 2. Hey, have a lovely day.
Oh, thank you. I appreciate it.
Turn that baby in. Take it up. Take it up. Good, huh? Take it up. Have a lovely day.
Finally cleaning my binder.
Come on.
Okay, so where you should stay here?